Timers and counters have great utility in PLC programs. This video will introduce one of the types of timers, and subsequent video will cover counters. The timer that we'll look at is a T-on timer in Siemens parlance. And for this type of timer, we have the input bit, so we enable the input, enable the timer. We have PT, which is the preset time, and this is a value that we load, and that governs how long the timer delays the output Q being turned off. And ET keeps track of the elapsed time, so the time that's elapsed since the enable input was true. Once elapsed time is equal to or greater than the preset time, then the output Q becomes true. So here is an example, and our input is true, and the elapsed time, apparently that went true 1 second and 404 milliseconds ago. So that elapsed time is less than the preset time of 5,000 milliseconds. And the result of that is the output Q is false. Once the elapsed time is equal to or greater than the preset time, then the output becomes true. And that's how the T-on timer works. There are other examples of, or other types of timers, and we'll look at those in another video. Whenever a timer is created, a data block is also created, and it has these tags. So we have the IN tag, which is to start, so it's the input to start the timer, and it's a Boolean type. We have the PT tag, which is a preset time, and it's a time data type, so it can have days, hours, minutes, etc. Q is another Boolean, and this is the output. And for a T-on timer, it is delayed by the time specified by the preset time. And then ET is another time tag. You can see here an example of using the preset time and the time data type. So we have 1 day, 8 hours, 57 minutes, 23 seconds, and 280 milliseconds. And once elapsed time is equal to or greater than that, then Q will be set to true. And as I mentioned, whenever a timer is created, a data block is created, and it can be named automatically, or you can name it manually. And it has those tags that we looked at before. So you can use these tags, and here's an example of using the Q tag. We have the timer, and when the elapsed time is equal to preset time, then our timer is connected to this memory bit, and so that's set to 1. And then on the next rung, we are checking the value of timer1 Q tag. So timer1 is the name of the data block, and the .q is the tag that we're looking at. So if that is true, then we're also going to set this output to be 1. So here's one example of a way to use the tags in a timer data block. This could have just been done with a parallel rung, but for illustration, we went ahead and looked at the timer Q bit. Here's another example, and this time we're looking at the ET tag, and we gave that the name current time. So here we're using comparison instructions, and the way these rungs work is if the value in this tag is greater than or equal to this value, then this is true. And if it's less than or equal to this value, then it's true. And again, we have on this rung comparisons for that elapsed time tag. And it has the name current time. And we're comparing it against the value here. So the operation of this program is that whenever this input is true, the timer starts and elapsed time begins to count up. And as long as that elapsed time is less than 2.5 seconds, output 3 is going to be true. Once 2.5 seconds have gone by, then as long as 5 seconds have not gone by, then output 3 will be off and output 4 will be true. And once 5 seconds have gone by, the mix motor will come on. There are two ways to reset the elapsed time in a timer, and this program shows both of those. You could use the reset timer instruction, so you tell it which timer to use, and whenever it's true, then the elapsed time in the timer is reset. Or you can just set the input line to false. And so here's an example where we start the timer and the output is false until elapsed time equals 5 seconds in this example. And then once that evaluates to true, then this memory, the Q bit for this timer is 1 or is true. And so the next scan, the next cycle for the PLC, this is going to be a 1, which will, this tag is going to be 1, so that if we examine if open, then that's going to evaluate to false. And so that would go ahead and reset the timer on the elapsed time on this timer. And so the effect of this is to just pulse the output. So this is one way of toggling or setting a memory bit once every so often. In this case, once every 5 seconds, we're going to set this an output or a bit to 1 for one scan. One more example of using the tags in a timer data block. Here we're modifying the value in the cycle preset, is what we've named the PT tag in this example. So we're using the move command. Whenever product A input is true, we're going to move this value into the cycle preset tag. So we're going to put, when product A input is true, then the preset for our timer will be 10 seconds. And when product B input is true, then the preset time for our timer is going to be 20 seconds.